These giant planets are being ripped apart by their own stars. They're called hot Jupiters, and they make up a big class of exoplanet. We've discovered over 700 total, but not so much because they're actually common, just because they're quite easy to detect, being large and close to their stars. A hot Jupiter is a gas giant planet like Jupiter that orbits its host star really closely, with orbits lasting less than 10 days, which is like 8 times closer than Mercury orbits the Sun. These planets form in the outer regions of their system, before migrating super close to the inner parts over time, even close enough for the star to begin pulling material off of the planet. This isn't happening to every hot Jupiter, but we can see many of them are losing bits of matter due to tidal forces and intense stellar radiation blasting away the gases that compose them. Most notably, WASP-12b, which orbits its Sun-like star in a little over a day, meaning it must orbit very close to its star. This proximity causes it to be distorted into an egg shape and lose around 6 billion tons of itself per second to its star. Like many hot Jupiters, it is tidally locked to its star, making one side in constant night and the other in constant day, with a temperature of about 2500 Kelvin. We also have evidence to suggest that it contains more carbon than oxygen, which, although is associated with diamonds and graphite in rocky planets, here it suggests the presence of carbon monoxide and methane. Another hot Jupiter, HD 189733b, catchy I know, is also slowly evaporating, and this exoplanet we actually know the color of. It's almost certainly a deep blue color, likely due to silicate rain clouds scattering blue light in the atmosphere. Although it's not getting destroyed as rapidly as WASP-12b, it occasionally gets a comet-like tail when its star lets out powerful flares. Hot Jupiters also have the exciting prospect of having larger moons that we could detect, again because they're so close to the star, but also because a moon similar to Jupiter's Io might leave a cloud of super hot sodium near that planet that we could detect. Lots of people think of exoplanet science as being focused solely on the search for habitable exoplanets, but I think non-habitable planets are just as interesting and worthy of study, especially since